it, because you had to install these things. But then where I want to go is that you had the tutorial to install both R and RStudio. R is the programming language. We're not going to go too deep into that. RStudio is the software we're going to be using to handle that language. And I will explain that more. But for the rest of the days, you need some packages. An R package is like a structure where you can store a lot of data that is just specific to one kind of analysis. Because R and RStudio are tools. They're not really an analysis process. So depending on your analysis, you may need some things that are very specific, and the packages are a good way to keep them organized. So all of these packages you already should have. You should have opened RStudio and run all of this. Did you do it? Did you have any issues with it? Nothing. Okay, good. That's great. Then we can start with the... Hmm? Yep. So usually when you're running this, if you got a message that said error, then it didn't get installed at all. And we should look into that. So if that happened to you, you should tell Guillermo right now, or Victor as well, and they can help you. They can come close to you and help you. Okay. Okay. Now, could you all please open RStudio? So this is how your screen should look. You should have RStudio open, and meanwhile the rest of you can also download . All good on this side? Yeah, you have RStudio open now. Good. ¿Agarra más grande? Bigger?
Just wait.
Sure.
I will point it here. In the RStudio, there's here a section that says package. Some of you are trying to install in that section. Don't do that. In the documentation of the guideline, we have some lines of code. You just copy that lines of code here, and you run it. Because not all the packages can be installed through here. And some of them have like something that says bioconductor, so then they cannot be installed from there. Okay, so in the guideline, you just copy the lines of each package, put it there, enter, and it will install, and it will be okay.
Okay, so now, Guillermo, just have it centralized. So this is an important moment.
Yeah,
because if you miss this, you will miss all 6 days of practice.
Yeah.
So it is. So really speak up if things are not running, or things are not copied, or things are copied in the wrong way. So we make sure today, because this is what I call the baseline, that we're all on the same page and that things are running all at the same time, right? But yeah, let's keep it central. So the first step, Luisa, is that they need to have installed RStudio.
RStudio and R.
And R. Okay? So.
That's everyone installed.
Exactly.
RStudio. So you type RStudio in your Windows bar, the program here, and then you click it open.
Is that the case?
Like this. You should get the app already when you type RStudio.
Is there anyone having an issue with that?
You're way more shy in the afternoon. I think it's lunch.
So RStudio I'm just going to go by personnel. Yeah. Is it installed? It's installed. Okay. Okay. Yeah. Big. I'm just going now through five. Is that everything installed properly? Here you are working right? No? It's not installed? It's installed. Guys in the back? Is it installed? Okay, installed? Yeah. Is it installed?
Or like your this is like the interface of all your books. That open and if it's the same, I mean if it's a link, and then there you install the package. If you go to the let's have the other studio everyone and then we can move to the back. But you need to copy that line everything. The whole that and then you paste it. When you have internet connection. Yes. And then enter. Then try to remove the others. And try to find
This side is great. Good to go.
Okay. Next. Guillermo. 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 Here, this side is ready to go.
well,
Okay?
now also
Yeah. I think this side is also ready.
Yeah.
Yeah. Everything's running here.
if it doesn't say error, warning, we are okay with it. Error, no.
So if it says warning, it's okay.
If it says error, central. Central. No, the people were talking here. So, okay, let's give it central.
So if it says warning, it's okay. If it says error, no okay. Okay?
Right. And the copy.
Yeah, when they are open.
Yeah, I can wait. It's fine. Yeah. But this side is good too.
If you already start R,
We are loading packages now, right, Lisa?
You don't need to do that now for the exercise. Is that so? I assumed everyone would have installed them, and that's why I wanted to check that first. But for this very small exercise, we don't need the packages. So what if we just leave the packages as a last step and we proceed with the exercise? I think that's better.
Yeah, good.
Okay, then please pay attention. Leave the packages aside for 1 minute. The error doesn't matter. We'll go back to that, but later. Okay, so R and RStudio. Maybe you already read a little bit of that. R is a programming language. There are many of them, but R is the most widely used among biologists. Why? Because we have RStudio available. So RStudio is a super tool. I really, really recommend you explore it as much as you can. We already have code set. We ourselves, Guillermo and I, are writing the codes that you're going to run throughout the weeks. So you don't need to learn all of this right now, but my suggestion is right after the course, you should get into it, click all the tabs, read everything, because it's so useful. So RStudio, mine looks a bit darker, but that's okay because you can also change appearance and things. When you explore, you will see. So with RStudio, we have 4 panels. In here we have 3 right now. I'm gonna open the 4th one because it's not always automatically open. So if I do this, I have now the 4 panels, the traditional panels from RStudio. So one in each corner of the screen. You can change the sizes of the panels as well, however you want. So if you drag the divisions, you can just change the sizes. Also from here, if I can make it, yes. So what are these 4 panels? The one in the left up is the source. So this you can use as a notebook, basically. You can write all your code there, and that's actually what you're going to see in our practicals. We already have all the code written in that panel. And there you can have your code, but also comments, some text as well. You're going to see it in the small exercise. So that is basically, that's why it's called source. That is the source of everything that you're going to do. You can write it there, and it's just written there without being executed. It's just there, ready to go for when you start your analysis. Then, on the left down, we have the console. The console is the one that executes everything. And as soon as you execute something that you had written over there, you will see it in here. So, for example, I think you can see the letters. I hope you do. If not, please tell me. If I have 2 plus 2 written in here, it's not being executed right now. You cannot see the letters? It's too bright. Yeah, but I think the complaint is the lights. Is it? Maybe we can change the appearance for this. It's better like that? You can all read it? I think they can read. I think we can see it now. Yeah, but we don't need so much. Okay. Everyone sees now, definitely. Okay, good. I was gonna get very worried if you didn't. Okay, good. So I have an expression right there. We know the result of that is 4, right? So it is there. I'm not executing it. It's just written. But as soon as I run it, it should appear over here in the console and also give me the result because it's executing it now. So whenever you have one line, the way to run it, there are 2 ways. You can either select all your line and click on run, and that's what is going to happen. So it prints again what you executed. It reminds you, you just did 2 plus 2, and then it gives you the result in white. So that is what the console is for. You can also directly type code in here, in the console, so 2 plus 1. And it works the same, but the nice thing of the R script is that it's like your notebook. You already can have it there, because as soon as you go out of RStudio, this 2 plus 1 is going to disappear. This history is going to go away. So that's why you want to have everything saved in your R script, in the source. And now we go to the panels in the right. These have multiple tabs, as you can see. I'm just going to explain the ones that we're going to be using, and the ones that I honestly I only use those ones. I don't use everything when I do analysis. So this one over here is the environment. the environment has all the variables and all the data that you are saving in your session. And our session is every time you open R, you run things, and these things existing here, you know? So if I do sum, and I do 2 plus 2, sorry, you see that now it changed over there. I have some values. The name is sum because I assigned a name to the variable, and the result is 4, and that is saved in my environment. So in this space where I'm running everything, it is there and I can access it. If I call the name of sum, it's going to give me the result again because now the operation has a name. It was assigned to something. So if you have these crazy numbers, you, for whatever reason in your analysis, you have an operation that looks like this, it's going to get very annoying and prone to error if you have to type that all the time. So the idea is that you assign a name to it that is easy for you to remember and also to type so that you don't have to do that again, right? You just assign a name, like with sum, and it'll give you the result without having to type everything all over. Then, this is the last panel that we have to explain now. So first we have the files. So everything that you are running in RStudio is happening somewhere in your computer. And then in that panel, you can see which files you have saved in the folder where you're running RStudio. Where can you see this folder? In here. So this very long line that I have here is the folder where I am running it. So if I go to my PC and I open the folder and I follow this, then I click on this, desktop, this folder, this one, I'm going to find that location, right? So that's where you're running it, and it happens that I have also these files exactly there, where I'm running R. So I can open them, you can see them there, you can upload data from there. We're not going to get into it too much, but it's a way to interact with the files that you have in that directory or folder. And then another thing, a very, very good advantage for RStudio, and a great reason that the biologists I know use RStudio for the analysis, is the plots. You can see the plots right there, and not many programming languages have this. Usually you just have to write all the code, cross your fingers, and hope that the plot that you want is actually being produced, and then check later on. But with R, you don't have to do that. You can generate your plot and immediately see it in the plots tab. Right now it's going to be empty because we don't have any plots, but in the exercise we will have some, and you will see them right there. The other thing is packages. So I think some of you are already familiar because you were trying to install with this. This is the list of packages that are available for download in a basic manner, but you have to keep in mind that in biology, we don't use it in a basic way. We use it for a specific analysis for biology, and we use packages that other people create and that the creators from RStudio just didn't do. So that's why this is not complete, and Guillermo was saying that to you. So, but you can find a great deal of packages in here. You're going to have the name in the left. There is a little white box. When that white box is checked, it's because you already loaded that package. So it's not only installed, but it's loaded. Those are two different things. You can install a package. That means you retrieve all the data from it. And when you load it, you make it available for use in your current R session. That is it. And the last one that I want to show you is the help tab. So this one is very useful. If you have functions or something that R is doing that you don't really know what's happening there because you took the code from someone else and they just have something written, but you don't know what's going on, you can come to help and type in the name of the function. I think Guillermo was already using this for some other thing, and we have the help for this function, and there's going to be a description, also how you can use it, and some examples, even documentation by the end. So this is very useful. Okay, so any questions? Yes? Yes, if you close RStudio, then yes, you need to load it again. Not install it, the installation is only done once, but loading it, yeah, every session.
Thinking the way that Arch is kind of a program that contains many programs. So every time that you go to your laptop and then you want to do a phylogenetic tree, for example, you open the program that you have to do the phylogenetic tree. So in RStudio, it's the same. Yeah, you have, this is kind of the administrator of all the programs that you have, and then you go to packages.
Yes.
And then here you have all the programs that you need for your research. Yeah? And then you basically click here, and then it says somewhere where,
What?
where are we? That the package is loaded. Can you click in one? Yeah.
What do you mean?
Click in the box.
Ah, yeah, of course.
Yeah. Yeah. Library access whatever. Yeah. That's loaded. So then the package is now active.
So, can I do a comment? Yeah. So when you have a lot of packages, it will be annoying to be clicking all of them
And
every time that
scrolling,
you open
yeah.
RStudio. So normally what we do, you see that when we click it, it appears this library and the name of the package. So once you have the package installed, normally we'll have like a list here that will say library and all the packages that we need. So library package 1, library package 2, and then you can just run that lines here and then it will load the package. So then you don't have to go box by box looking in all these lists that sometimes is really long.
Any more questions? No. Okay. Then could you please access the Google Drive in the small exercise day 1 and download 2 things. I can show you. So you go to day 1.
First step
And
is
then-
small exercise. Huh?
Yes, and I don't know why I have 2 versions, but open the one that is the biggest. Then we download it. You already downloaded it in here, right? It's already. And data CSV, because we're going to use that. So that is a comma separated file. That is basically an Excel file with data in it. You will see it. We will open it with RStudio.
We do a small check to see that everybody.
Okay. Yes, thank you.
So they have to open the data.
Download both of them and then put them together in a folder. Maybe in your downloads is already enough.
Create maybe a folder in your desktop and just put practical R, and then you download that data.csv and a small exercise.rmp, and then you put that file in that folder.
Not before your session, set as working. Pero está creando una cartera, va a ser para que empiece a hablar, set working monitor.
Just create a folder in your desktop with the name of the practical day 1. And then you download that to file and put it in that folder.
working directory, aquí te va a aparecer la línea. Entonces lo suyo es que tú le digas cómo vas a estar accediendo a esa carpeta porque estás trabajando, te la copias aquí, y con los paquetes que actualices también, y ya le dices, y puedes salvar este documento para después y le pones data processing o lo que sea, ¿vale? Super.
Are we done then? I see some issues still. All good now then, right? So I think many of you already directly opened the file, which is good. So I'm also gonna open it. I can directly open it from here because I'm already in the directory that I'm gonna use. So there it is. Okay, doesn't matter. This is a bit too big.
Yeah, the global section.
No, con el control menos. Maybe like this is better. Okay, so this is my notebook. This is the notebook I made for this exercise, and that is why it's in source. Okay, so as I told you before, we're gonna be running everything in one folder, right? So we should make sure that the session that we have right now is in that folder, which is the folder you just created with the 2 files. How do we do that? We go to session over here, and then you can see set working directory. So the folder where you're gonna work, and then choose directory, and then you can go to the directory that you created, exploring your PC, just as usual. And you click on it and say open, and that's gonna be your directory. So for me, it's this one that I already have. I say open, and then in the console, it executed something. Set WD. That is the command way of doing what we just did with the mouse. This is what's great about RStudio. You don't need to know all the commands because there are many things that you can do by clicking, which is way easier. It's more user-friendly. I can repeat this step. So you go to session over here in the top of the screen, and then set working directory. Gives you some options, and you choose the last one, choose directory. And when you click on that, it opens this way to navigate your PC. Look for the folder you just created with your 2 files. And then as soon as you're already in it, like I am, you say open. And that's it. And you should have something printed in here that looks like that, sort of. So set WD and then the whole name of your folder.
Okay, so are we all there? Yeah?
No?
Who is not there?
I will.
Yeah.
Should I do it once more, just so we're clear? Yeah? Okay, so also if you're in your folder, so you go session, set working directory, and choose directory. Once you are in, I'm looking for my folder, right? I know it's this one. It doesn't matter if it looks empty. Because this way of navigation, since RStudio is choosing a directory, it's only going to show you directories, not the files. So that's why it can look empty, but it's really not empty. You just say open as soon as you are in the folder. You open, and then right after, if you check the files panel, you should see your files, the files that are in that directory. Okay, so I think we're done. A quick way to check if you are actually in the correct folder is that you should see the files that you just downloaded and put in that folder, in this files panel. Do you see them? Great.
Files, yeah, and then you should see the 3 documents that you just downloaded. Yeah?
Okay.
Beautiful.
Okay. Good. And now we have in the notebook something to run. We can also have text, which we do. And then we can give it a quick read, and we all do it together. So before starting, we already did this. So we all have R and RStudio downloaded, up and running, because we're all there right now. And the packages, we can look into that. Whoever has errors or problems with that, we can check that later. But for now, we're going to do the exercise. That's true. I forgot that. I'm sorry. You should open this one. And then you click on it, and it will appear like this in the left up panel. Yes? Are we sure? I didn't hear. Yes. Okay, good.
Yeah, everyone could follow it? Yeah. If there is one lost, please tell us. Anybody who is not able to follow, please raise your hand.
Yep.
Raise your hand strong. Okay, at least one.
And it's gonna have to be the same.
Neighbors can also assist if there is a possibility.
Yeah.
Like if someone managed to do it,
You can.
if someone next to you cannot do it.
Yeah. So the thing with all these analysis and the rest of the days is gonna be the same. If you get lost in one step, you're not gonna be able to follow the rest because everything depends on the previous thing. It's a process. It's like a chain. So as soon as you get lost, raise your hand and ask for help, because otherwise you're just gonna stay lost. Okay, so if your screen doesn't look like this, raise your hand. Yeah? Ah, okay. Okay, good. Then we are now in the notebook, all of us in the left up panel, right? So, as I was already telling you, RStudio is a must-know tool. If you want to do analysis, this is the best way to do that, especially as biologists, because since it's so used by biologists, there are already many tools for biology. So that is great. You can load data, you can transform it, do operations with your data, plot your data, everything you can think of. You can even use it for artificial intelligence and things like that. So this is very, very useful. And one very good thing about both R and RStudio is this. They are open source, so you didn't have to pay anything to download it and install it. And since it's open source, that also means that people from the community, the users that use this, they can make packages themselves and share them with other people, and others can use it and give feedback. This doesn't work for me. Why? Please help me. And it's very interactive, so that is always great, especially if you're learning. So if you're just getting started with RStudio is definitely for you. Please don't uninstall after the course is done. Please. Okay. Now we're going to do very basic things as an example of of the things that you can do with RStudio. And we're going to create a data frame. So a data frame is a way to store data. It's basically a table, because data frames have columns and rows, so it really looks like a table. And it's the most common way of storing data in biology. We usually have counts or, mostly counts, or percentages. It all fits in a table, so we always use data frames. It's just the name, a data frame. Okay. So in our case, I made a very small example. So we're going to create a data frame with information of bird observations done in a specific region in the Netherlands. And then this table is going to have the name of the species that were spotted and how many times they were seen by the researchers that were out that afternoon. Birds seeing. Okay. So then we have a chunk of data. And I think you can notice that it looks a little bit different than the rest of the text we've been reading, because this is just text. It's like a Word document. You cannot execute that. It's just text. But then if you add a chunk of code, that is going to be the part that you execute and actually use in the console. And this is our chunk of code. So for now, what I want you to see is that I'm creating the columns that we're going to have in the data frame. One of them is called name, which has the species names. They're over there. And the other column is going to be observations, which has the observations for each of that species. Data frames are made out of vectors. Vector is a very simple kind of data in R. How do you know something is a vector? It has a C over here and then a parenthesis. And between the parentheses, you have a list of elements that you're going to have in your vector. That's it. It's like a list, but you can store it. So we're going to run this and create both name and observations. How can we run this chunk? Over here in the corner, I think it looks very small. There is a green triangle, like a play symbol. Click on it, and it'll run both those things, which you can confirm, because in the console, they just got executed. Did we all do that? Good. And then you can also see that it got executed because they were saved. Since we had a name and we were assigning them to the name, in the panel over there with the environment, you can see that they are stored. So they have the names that we assign to them, and inside the elements of the vector. So maybe you can try to do the following. In the console, why don't you type name, enter, and see what you get? I will also do it. And did you get the names of the species? Okay, great. I also want to mention a detail. When programming, it is very important to differentiate capital letters or spaces. So for example, our name has a capital N. If you type it without the capital N, it's just not going to recognize it. So it's very sensitive with these little things. Okay, good. It's good to keep in mind. Okay, I think we're all there now. Then we will continue. We have, so let's just recapitulate a bit. We have the two vectors with which we're going to make our table, right? Which are name and observations. Since we already have those, we can make the table. And that is the next chunk of code over here. So for that, we use a function that is called data frame. How do you know what a function looks like? It has some name, which is usually very descriptive. It tells you what it is doing. And right after, without a space, there are parentheses. That is a function. And inside the parentheses, you put the data with which you want to execute that function. So,
just one little thing. So, focus here on the left side that you have the line number, because before I was somewhere there and we were in the wrong number of line, and then that's why it was not working. So focus here in the left line, so you will have to run from the 45 to the 47, okay? Sorry, Luisa.
Yeah, no, that's great. Great addition. Yeah. Okay, so now we can make the data frame. We have the function data frame, and then both the vectors we want, each one of them will be a column, name and observations. If you run the chunk of code like we did before, so with the little play symbol, you should get something right below the chunk of code like I did. This. Did you get it? Do you have it? Okay, great. And then, since this was also a variable, because we had a little arrow and a name in the left, it got also saved in the environment where the vectors were. So if you check your environment, now you have something called df. It looks a little bit different than this one. And the reason is, the other ones were vectors, so they only have one dimension. But this one, it's a table, so it has the rows and the columns, so it has two dimensions now, and you can visualize it. So the way you visualize it is, over here, you can click on the name of df. Do not click the blue little symbol in the left, just click the name. And then a new tab should get open in the left up panel where you can see your table.
Yes, also look at here that everything that you do will be printed in the console. Okay, so for example, if you want to do it by command line, you just should do view, brackets, and within the brackets, the df, and then this file will come up. Yeah? Sorry? Yeah, so you see when you load the table, when you click here and you load the table in the console, there is always a command, view and the data frame in brackets, df in brackets. So if you run that, yeah, you will see the data frame. Okay, that's another way to open. Okay,
Everything.
We are all in the same place, right?
Yeah, everything that we do by clicks, there is a common way to do it, and RStudio will print it. It's not necessary that you know them, but it's good to see what R is doing. Although you can stick to the clicks if you're more comfortable with that. Do we all have the table? Okay, great. Another thing that you can see in the environment part is we have this very small description, we can call, of our table. So it says 5 observations of 2 variables, and that is a summary of the dimensions you have. So 5 observations because we have 5 rows of 2 variables, which are the 2 vectors that we had that are now columns in our table. So when you have huge tables, that is very useful. Okay, so now we have the table, the basic data structure that you're usually gonna use, and we can do operations with it or plot the info that is inside, and that's what we're gonna do. How are we running on time right now? Good? Okay, great. Then we can do operations. Yay. Oh, sorry. Oh, and the other way to get data, you don't necessarily have to write down all your columns like we did. We had 2 columns and we wrote them down. You don't need to do that. You can already have Excel files with your tables and just read them into R. So that's why we downloaded another file which was called data CSV. So a CSV stands for comma separated, what is the V? Value? Okay. So comma separated value. It's a simplification of an Excel file. And that's what we have right now in our folder, I believe, because you all told me you were in the correct folder. So if we run this chunk of code, we should get another data frame that is called df from Excel. And if you open it, like we did it before, so clicking the name in the environment panel, you should see a table that looks exactly the same because the Excel has the same we just did. So if I run the chunk of code and then I click on the name, I again have the same table. But this time I imported from outside, so from my PC to RStudio to work with it. So do we all have 2 tables now? Sorry, I can repeat. So you can also import data from Excel or files, text files, any file based on text into R. And what you have to do is, well, read CSV, that is a function. We know it's a function because there is a name and then parentheses right after. And what this function does, you can see that the names are very descriptive. It helps you read a CSV, so that's good. And then you just have the name of the file because that's exactly the name, which we can see over here. And if we run the chunk of code like we have been doing, you should get this value now in your environment, and you should have the line in the console as well. So if you click the name in the environment, you should get another table that looks the same. All good?
Yeah.
Yes?
I have a question. If the name of the file is not in our working directory, will the file open also?
No. It will tell you that it cannot find the file. So right now we're typing only the name because we know it's there in our directory. But if it's not there, then you write in here the path. So we can also open it like this. If I do, oh no, what is the, in R, what doesn't matter. We had, I think you remember we had a line where we had the whole path, right? When we changed the session. If you did this full name, copy, paste it in here, like this, that is the full name of the file. So it's not only the file, but where it is. That is the complete name, which looks a little bit frightening. That's why we try to work always from the same directory where the data are, because that way the names are short. So if you run this, it should work as well. But we're gonna stick to our pretty data CSV for now. Any other questions? No? Okay, then we can keep going. Now we can do operations with our data frame. So we have the info. We learned how to do it ourselves and also how to import it from a file. It doesn't matter which way you do it. The important thing is we now have the table, which is what we're going to use. So we could check, for example, how many observations there were in total. So basically, if you open the table, what I want to see, to know, is how much do all of these sum up. And right now it looks easy to do, but if you have a very, very big table with 1,000 rows, you're not going to do that in your head. You need an operation for that. And so there is a very simple function in R that is called sum. If you want to do something and you don't know the name of the function, which will happen many times, you can go to Google. How do I sum this, or how do I do this? And because of the community and it being open source, you will find answers. So for this we're gonna sum, but only the values of one column. Because if I did sum the data frame, what R would try to do, because it's so obedient and it takes the orders literally, it will try to sum everything that we have, including the names, which are letters, and we cannot sum. So it would give us an error. We really have to be specific with it. So what we're going to do is just use this column that is called observations. And the way we can do that is, let's close this one. The way we can do that is we write df, which is the data frame, and then with this $sign, you can divide it into the columns, so you can select one column only. And it is observations, the numerical one. That's the one we're going to sum. So if we run this chunk of code, we will get the sum of that column. So let's run it in the green symbol, and then we get 48, which is the sum of everything that was in that column. That is a basic operation that you can do. Always keep in mind, if your data is numeric, if you have maybe some letters, then mathematical operations like this will not work. So that's why it's very good to have your table and look at it, because that way you see what kind of data you have. Okay, are we all in here with our 48? Yeah? Great. So I was thinking, since we already have this total, maybe we can see what the percentages are. Instead of only having the counts, make it into percentages, just for the fun of it, because we like RStudio so much. And for that, I was thinking of making an extra column. So instead of having 2 columns, we're going to have 3. And the new one is going to be called percentage. So it should be in df in our table, and then $sign, and we put a new name. If we put a name that already exists, it'll just replace the data. But you can just make up whatever name, and it'll create a new column with that name. So we will have a new column that has all of this operation, which is, it's going to take each value in observations, multiply it by 100, and then divide it by the total, which is how you can do the percentage. So if we run the chunk of code and open df again, so click on the name of df, now we have 3 columns. one called percentage, with the results. Good, right? RStudio is very cool. Okay.
Lisa, just one second.
Yeah.
So are we all here? Anybody's not here? Yeah. One, two. Anybody? That's fine.
Yeah, just raise your hand. Don't be shy. Remember, you can check the number of the lines to see if you're in this same part. All good? Okay, I think we're all good. Great. Okay. So we made an operation. We also modified the data frame by putting another column in it. And we now know how to create that data frame in two different ways. So that's nice. And now I have a question for you. So one way to know if your percentages are okay is that they all should sum up to 100, right? 100%. So how will you check that in the new column that we just did? Good. So then we can write sum, right, as a function, parenthesis, and then it's in the table called df, but we only want to do it with one column, right? So $sign, and we can select. RStudio is so kind that it usually gives you all the options of your columns, and with the arrows, you can just go up and down, select it, enter, and it auto-completes the text for you. And then sum of all of this, enter. 100. Good? Sorry? Are you sure? I think so. All good? Do we have 100 in our console? Great. And now we can get to a very fun part, which is making the plots. And we are usually very interested in that because maybe we have a presentation at a conference or for a paper or even maybe just for yourself so you can see your data in a visual way and see, okay, well, what's the next step in my analysis, right? So plots are very necessary, and since we're using RStudio, which is great for plots, then we should make plots. I want to do a bar plot right now with all the observations that we have. So the bar plot would have the observations in the bars, and then in the x-axis, each species name, right? So we can do that. There is a function that is called bar plot. See, this is what I tell you. The names of the functions are very descriptive. It's very nice. So for bar plot, for functions like this, there is an order. So first you have an argument. Arguments are this written expressions separated by commas. So df observations is the first argument. The second one is the second argument, sorry. So how many arguments do we have? If they are separated by commas, how many arguments do we have in that function? How many? Great. We have 3. So the bars are going to be the observations that we had in our table. Then the names in the plot, so the x-axis, that's going to be the names of the species. So df name. And then I also wanted to do a main title for my plot, which tells me this is a bar plot of observed birds. If you run the code like that, because of the way I wrote my notebook, the plot will appear still in the top left corner. But if you go to console, click on console to make sure that you're going to be there, and then go 1 time up with the arrow of your keyboard, and this saves the history. So you can access the command that you just did. You don't have to type it all over again. So I do it again. Like this, click on the console, then 1 up with the arrow. It shows you what you just run. So let's do enter. And now we get the bar plot in the plot panel. All good? I'm going to check anyways.
Who didn't get it? Who is lost? Yeah, all good? I think you are having fun, right? All good? Yeah?
In the plot panel, you can see like there is also like functions that say boom.
Oh yeah, that's true. We can click zoom in here.
It will open like a new window, and then you can see like bigger, or you can adjust it because sometimes you just need it in a square,
Yep. So I'm not sure everyone heard what Guillermo was saying. I'm going to repeat it. Maybe the bar plot doesn't look that nice now that you have it there. So you can click on zoom, which is in here in the plot panel. So if you click zoom, it'll open a new window with only your bar plot. So it's going to look bigger and nicer. And that way you can close. You're not going to lose any data. Just close it and it'll be fine. Your bar plot is still there. Yes. This is the basic function, but there are many functions to do it.
So I don't know what it is, but normally it's doing a pop-up. This is doing a pop-up. So
No,
I think it's an option, an extra option that I never saw it.
that is a configuration thing in our
It's a
studio.
configuration.
Yeah, that, but it's fine for now. Yeah, it's okay. We have the bar plot. Nice. And then, just because I was having so much fun making this exercise, I also have a pie chart. And the function is called pie. Very descriptive, again. And then we also do it with the observations. The names of each region of the pie chart is going to be the species name. And it also has a main title that I wanted to add. If we run that chunk of code, then we get the plot again in this in the notebook because of how I wrote it. So, but if we go to the console, forward once, enter, like we did it before. So click on the console, one up with your arrows, enter. Then you get your pie chart in the plots panel. And then on this one, we can also do zoom. So we click on zoom. Well, it's not that much bigger, but it is bigger.
Everyone is there? Yeah? Amazing. We have 30 programmers.
Yeah,
Good.
great,
Yeah?
great. So this was the exercise. This was the coding part. Right now, I also want to talk to you a little about extra tools that you have from R. Because, well, these plots, I don't know about you, but I would prefer a prettier plot for my paper than this one. And there are many, many options to change that. And there is a website that is great for this, which we can go to the navigator right now and check it. If you type R graph gallery, like this, R graph gallery in Google. And then you do enter, and the first result, that is the one we're looking for. Help and inspiration for our charts. That's the name they have. Yep.
So now please go to the website that Luisa is telling you.
So as soon as you look for it in Google, the first result, I can show it again. The first result, that's the one we click on. And we click. And this is the R graph gallery. So this has a lot of options for plots. Personalized plots with different colors. Maybe you want to change the size of the font or the position of the legend. And they all have it in here, very nicely explained. So what I really like is this. So based on the kind of plot that you want, if you scroll down a little bit, you're going to see many options for plots. So violin, density, histogram, scatter, heat map. There's also bar plots, which we did already. Many, many of them. And then let's say you want to do a plot from this. So I want to do a box plot. I'm going to click on box plot. And then they even take the time to explain, in case you're not that familiar, you just found, oh, this plot looks interesting, I wonder what it does. They're going to explain it to you as well. They have warnings, introduction for things. This should have more images, but it's a bit slow, maybe because we're all there. Yeah, but then they can look like this, which looks way nicer, I would say. Okay, it's loading now. Great. So what I was going to say is that they even explain what the box plot shows. So, and you can check there, they have links, extra tools. And then you can even choose, I want a basic box plot, or maybe one with the individual observations or a violin chart. So if I go to basic box plot, let's click on basic box plot. They give you the code. They give you some data that they create for the example, and then they give you the code to do the plot. So if it all works out, and then you want to do it with your data, you just have to replace the data and just keep the code of the plot, and you will have this very nice plot. So for example, look, this is the code that they're using, and I think you should already know some things in here. So library, we saw that that's the way you load a package, right? So they're loading some packages over there, and then they create the data set in the same way we did. So they have a name. I'm going to do it with the cursor. Like, can you all see it? Yeah? Okay. So they have the data frame function, which we used. And then they have vectors. How do we know they are vectors? Again, the C and then the parentheses, right? And they have a name, each of them. So we know these two are columns in their data. And then they plot that data. So all of this, we're not going to run it right now. Well, actually, I think we can run it. So I think in the markdown, it should already be there. Do you see a very big chunk of code in the end of your notebook? It should be there. If it's not, then maybe you downloaded an older version of the notebook, and it's fine. You can just look in here, because this is the end of this intro. So what I did was copy everything and paste it. And now if I run the chunk of code, you can also do it, the ones that have it. Oh, I don't have this library. Guillermo, how do you have this? Okay. Yeah, we need to install them, but since we were having issues installing, I think we can leave this for later. But then my takeaway message would be, you can really go there and retrieve whole codes for very cool plots. And then, so this is for plots. And then one last thing that I wanted to mention, I think you must be tired and it's time for a break, but then one last thing is that we saw that there are many packages, right? And the packages look so abstract and you don't know what they are or what they have. So you can usually look for documentation on them, because everything has to be documented. So if we go, so there was this one package in the requirements in the guidelines that is called MetaGenomeSec. If I Google it, then let's do MetaGenomeSec. Whoops, like this. MetaGenomeSec. Enter. And then I want you to look for the link that says GitHub. Maybe you're already familiar with GitHub or you've heard of it, but GitHub is a website, basically, which serves as a repository. So people do projects in there, code projects, and they save them and share them with some other people. So let's click on the GitHub one. Did you find it? It's called HC Bravo Lab, MetaGenomeSec. And then we click on it. It's like the 4th, 5th result. And this is how the GitHub page looks. Anytime you see this logo with a little cat in here, that is GitHub, the one in the corner. And then this was done by Bravo Lab. So these are usually collaborative projects. That is why GitHub is so nice, because you can have a file of code and then many people can contribute together, and this keeps track of the changes in a very, very organized way. So this is very good, and you can find papers where they develop a tool and they simply share the GitHub link with you. So this is very widely used, and usually if you scroll past all these folders, you find documentation on it. So you have a description of what it does. Sometimes they explain how you can install it. Some of them give example data that you can use to run it. It really depends on the people that did this. And they sometimes have websites or wiki documents that really talk about everything that the functions do. So if you're very interested in it, or you're writing a paper and you want to be very specific in the methods, you can go and access the documentation and try and understand better what is going on in there. And that is it. So thank you very much. I hope things are clear. If you have more questions, then we can discuss about them. I hope you had fun. Okay. Okay.
Okay, that was a fantastic beginning on bioinformatics. I hope you got the flavor of real bioinformatics. All right, so EOS was very particular. That's the reason we spend a little more time here. You need to get out of the mindset. Bioinformatics is something which is beyond our reach. It's not like that. It is very well within your reach. Thanks, Luisa, for making bioinformatics very simple. Right? Thank you so much. Yeah. Let's break for tea now. Then let's come back and continue the practical. Yeah, please.
Just one comment.
Yeah, please come here.
It would be nice, and then in the guideline you have some links and how I learned to program in YouTube. YouTube videos is full of videos to do a lot of things. So if you have time, maybe today or when you have time, just play around, try to repeat the exercise and get familiar with them.
And so this morning, Dr. Gavala, she was talking about, the chat GPT. Chat GPT also, seems to be super good, right?
Yeah, I use it a lot. For example, ChatGPT, you can use it instead of like as you can look it for GitHub, you can just go to ChatGPT and say, can you explain me what this package metagenome sec does? And it will explain you quite in detail. So now a lot of bioinformaticians use ChatGPT a lot because it's really easy and fast to look for information.
Yeah, maybe one last comment, and then we go to the break. This was quite some information about the basics. So the coming days we will be using this again. So if you feel still a bit, shaky about this, just, try to, practice again. And if you have questions, come back to us again, right? So we're here to help. So just ask.
I think that's very important that you practice. So you take this exercise and then you repeat it at home, and maybe even you can take some of the plots that Luisa showed in the graph gallery and try to reproduce them and try to encounter the problems. I am not by informatician by training, but yeah, I know how to do a lot of things in R. And for example, you always get afraid when you get a red message of an error. Don't panic. Yeah. So there is no drama on that. Well, there is a bit of drama, but just read the message and then, try to solve it. And for example, many times it's just installing another package that is missing, like you have right now, tidy diverse.
You type something wrong.
You type something wrong, or
isolation of rhizosphere microbiomes. I think the group already we formed, G1 to G10, and you find your place in the lab where it's already labeled G1 to G10 with your name written on top of that. So there is no issues, right? So identify the location where your slots are allotted and take that position, right? Then we are going to start the eDNA of rhizosphere microbiome. So Raymaker's team is already there to teach you how to do that. Hands-on experience, and all material is ready. Protocol is already with you. And now you get into the practical room and start practicing that rhizosphere eDNA isolation. Please proceed. Yeah. Thank you. For online attendees, from here on, you have to only see how the practicals are being held in the practical room. And we will webcast that particular practical through YouTube. Thank you. Yeah.